All right, cool. So instruction encoding, yes, this stuff. So line 4, basically this lab is separated into 2 parts. You have an encoding section and a decoding section. Encoding is just going from the instructions to the binary. Decoding is the opposite. Right, and so when we look at, so for example, for add I, we have this instruction add I x5, x0, 0, right? So first I look and I say, okay, what kind of instruction is it? Is it an arithmetic or logic? Is it a load store, or is it a branch or jump? In this specific case, it's going to be an arithmetic because it's an addition operation, right? So I'd mark that. Then I'd figure out what instruction format it is in. All right, is it an R format, S format, SB, J, or I? Well, in this case, it's an I format. And the way I know that is I look down here. There's a, right, and what I can look is see, okay, this is the actual design of the different types, right? So if we look, right, with the R type, S types, and B types, they all have destination registers, but with the I types, it has an immediate and only one register, right? It's RS1, but it doesn't have an RS2. And honestly, so the easiest way to kind of be like, okay, which one's which is honestly, I would say Google the different types and see why they're, how you can tell which type is which, right? And I think that's classified on the green sheet as, hey, this is an S type instruction, or hey, this is an R type of instruction. So basically, if you're not sure what kind of instruction is, a type of instruction it is, Google it. Not all of them, like on a case-by-case basis, if you can't figure it out based on the green sheet. Right, the idea here is to use Google as a tool because that's what we use in CS as a tool. So just like use it as a tool. So add I, right. So now that I've realized, okay, I know it's an arithmetic and I know it's an I format instruction. Okay, based on that, I now have the general format of how it should be broken down, right? And I think there's something weird with the endianness of the way these instructions work, and it always makes my brain hurt. But I don't think it's a huge deal regardless, but basically it's dumb and annoying. Okay. Right, and so for something like, so as I'm continuing, so now, right, I'm going to look and see, okay, I need to encode this. Well, for an add I operation, we can either, there's a couple different ways we can look at it, but we know this is an add I. So the first thing we need to do is opcode, right? And so what I'm going to do is I'm going to look, I'm going to find the add I operation. Right, because these binary encodings are done at a hardware level for RISC-V processors, right? Where's that I? Am I just being blind? Ah, here it is, right? So this is at a hardware level encoded, right? There's certain aspects of this instruction that are just hard coded, right? The registers are not hard coded, right? Because it could be a different register, or the immediate value could be a different intermediate value, but the actual operation itself, right? That's hard coded. So we have so in our opcode, I see I have 001, 0011, right? And then if I look here, et voila, right? 001, 0011. Right. So then I can see, okay, well, what's this 3-digit number right here? Right, that is the func3, which is to say it is another one of those hard-coded values that can indicate that indicates further kind of complexity. So like this maybe lets us know, hey, this can be immediate or something. I'm not saying that's exactly what it does here, but that's what it can do. So in this case, it's just 000, right? But it could be something like 010 or 011, right? It could be anything from 0 to 7. Yep. And then so right now that I've gotten these kind of the hard coded parts done, right? I gotta look at my other parts. What else do I have? I have for add I need the destination register, one of the register target registers, and then the immediate value. And so I'm gonna look and I'm gonna see, okay, Well, what is the register target, right? In this case, it's the X5, right? So this would be 5, right? So this is literally just 5 in binary. Okay, what's the other register? RS1 would be 0 because it's 0. And then what's the immediate value? The immediate value also happens to be 0. And that will occupy these 2 cells, right? Because at the end of the day, right, the computer just doesn't see this as like, cells. It just sees it as this is one big binary string, right? And so indexed, right, we can actually index these, right? If we consider this one here, the 0 index, and this 0 here, the 31 index, right? What it allows us to do I always confuse myself looking at the stuff sometimes. It's very like, it's not that hard, but there's a lot of weirdness where you can kind of get yourself confused. But where was I? Sorry guys, I've got the memory of a goldfish. The immediate value, right? So immediate value of that from 11 to 0, right? And so that's how you populate that value. Specifically, I can populate this by saying, okay, where's the 11 bit? What the hell? Give me like half a sec, guys. I don't want to say the wrong thing here and confuse y'all anymore. But there's always something weird that happens with this one. Just bear with me. But yeah, right. So, okay, I'm overthinking this. So 0 is the immediate value. These 11 bits here are 0. And voila. So does that sort of make sense at a basic level, guys? As a quick run through of like how this sort of works, right? And then you would just literally convert that to hex. So in there, and that's because that's the equivalent of, that's basically like, if you guys do this, it's functionally like hashing it. So that way we can just check this value. And if you get this value right, you probably got it. It means you probably got most of it right. Any questions? Okay, I'm going to assume there are no more questions. Yeah, but basically for this one, but yeah, for the second part, right, you're actually given the instruction word in hex already. You just got to go the other way around. And there will be some more weirdness, just fair warning. There's going to be a lot of weirdness with some of these other things, like particularly jump type instructions and such. It's where you. That's what I wanted to remind y'all. Okay, so the way that we actually construct something like this, right, is if we all because we know. I'll probably throw the link on YouTube or something. It'll be on the website. Gotta get that ad revenue, guys. But if we actually look at like something like that for the jump, the immediate value, right, we have 20, 10, 1, 11, and 19, 12, right? Like, what the hell does that mean? Right, because that looks really weird. And what that means is that's how you basically do the ordering of the bits for this indexed portion. I need to find a good example, but yeah, so I'm going to leave that for there, and then I'll probably come back later and do a little bit more detailed about how this works, because I think it's actually not that bad, but I want to refresh myself before I start talking about it more.